Okay, Mr. Bowden here, and we're going to be going over our lab on MSPS 2-3 and MSPS 2-5. And I've linked those activities in the file for this week's assignments. But it should look something like this. I'm going to take you through the lab real quick and get acquainted with the goals and the outcomes, and then also take a look at some of the materials. All right, so the first thing we'll notice is that the first goal is to ask questions about data to determine the factors that affect the strength of electric and magnetic forces. And we've already read about those factors, but we're going to test them out today. The second goal is to conduct an investigation and evaluate the experimental design to provide evidence, right, and data that fields exist between objects exerting forces on each other, even though they are not in contact. Right? And so what we have here is we have a number of 6-volt batteries and varying amp outputs. And I have those over here to my right. And I've gone through, lost some sticky notes here. But I actually used a amp meter, which you read about. And I actually tested the amount of amps, and that's what this buddy does here, flowing through each of these batteries. Now, they're all 6-volt batteries. So 6 volts is the amount of potential there is for electrons to flow. But each of these is dying because we've used them over the years. And so if we notice, each one of these, starting on the left, puts out less amps. So what we're going to see is, based on the number of amps or electrons flowing through a wire, how will that affect the force of attraction in that magnetic field in an electromagnet? And then we're also going to just look at how many wraps on an electromagnet in the ferromagnet will affect. So I have 50 wraps of wire on a coil with the magnetic core with these bolts. 75 wraps. This is my 100 wrap tester here. And then I go to 125 and 150. So we're going to look at two variables and see how those affect the force of attraction. We'll be seeing this based on how far it pulls a paper clip, what distance it pulls it from when it's actually connected up. So that's going to be our lab and what our write-up will be based on. All right, it's taken me a little bit to get my act together here, but I've wrapped these different amounts, 50, 75, 100. This one says 113, 125, and 150. This one has a larger gauge wire than this one right here. I think this one's kind of the odd duck out. So even though it says 125 wraps, we saw that the gauge or thickness of the wire has an impact. So this one might kind of be an outlier. So we'll take a look and see how this impacts it. So for this first experiment, I just want to first off show that this is in fact an electromagnet. Notice this is my highest amperage output, 6-volt battery, 6 volts, right? And so this one's putting out the most electrons. So I'm going to connect. First off, I'll just show, look, nothing happens, right? And just show what we've seen over the last couple weeks in our videos. The relationship, you see a spark there between electricity and magnetism. Where there is electricity, there is magnetism. So that's pretty cool. And you release, let go of the power, and they fall off there. So it's an electromagnet produced by the flow of electrons. Where there is electricity, there is a force. And so let's just take a look at how this has an effect and how we can change that force. So in this first clip, we're going to be filling out the first table here, which you already have filled out for you in front of you, but this is how I went about it. And we're going to start off at the bottom at the 6+ amp battery. And we're going to see how far I have 100 wraps. I'm actually using the 75. With a 75 wraps, how far will it pull the paper clip? And we'll see how changing the amount of amps or electrons flowing through a wire has an impact. So the first thing we're going to do is we're going to connect up this 6-volt, 6+ amp battery to our electromagnet. We're going to calculate the distance pulled, and we'll just average it or kind of angle it down and see about how far it pulls the paper clip from. So right there is at about 1.8, and just back it up again. About 1.8-ish. This is not an exact science. Yeah, 1.8-ish. So I'm going to undo that so as not to kill the battery. So I go up and I put in 1.8 centimeters, which equals 18 millimeters. So now I've switched it out, and now I have my 5.3 amp battery. I'm going to connect that up. .5. So we still have the 75 coil electromagnet. 1.6. 1.7. We'll average that out to about 1.6 on that one. And we'll plug that into our data table, which equals 16 millimeters. All right, we'll switch it out. We'll bump down to our 3.9 amp battery. So we're getting less and less electrons flowing through the wire. All hooked up. 1.2. Sorry if you can't see that. Doing my best here. 1.2. And about 1.2. So that's pretty consistent. 1.2. Type it in. 1.2 centimeters, which equals 12 millimeters. We'll probably graph it in millimeters. All right, let's go over to our 3.2 amp. Hopefully we're noticing a relationship here. As the number of amps go down, the electrons in the wires are decreasing. Still have the same number of wraps, but what we notice is it does not pull it from as far. So let's try here. This is with 3.2 amps. That pulled it from about 1. Kind of looking at the angle too. Yeah, if you look at the bottom here, that's kind of where I'm taking my measurement from. So that was also about 1. Right there, 1 again. So at 3.2 amps, let's unplug that so as not to kill the battery. Pulled it from about 1 centimeter, which is equal to 10 millimeters. I'm going to pause for a second, regroup. All right, we're back at 2.4 amps. Hook it up. Here we go. Should have a good connection. 2.4 amps, the least we've done so far. Still 75 wraps. That was about 9 millimeters. A little bit more on that one, about 1. And about 9 again. So I'm going to average that one. I'll say 9.3. 9.3, or actually that would be 0.93 centimeters, which is equal to 9.3 millimeters. All right, let's try the 2 amp battery here. Get that one hooked up. Okay. 2 amps. Zero it out. How far does it pull it from? Whoa. Wow, that was down at 0.4. I want to double check our connections, make sure everything's good and tight on here. Also over here. Okay, let's try again. 0.4 on that last one. 0.5 there. Set it to 0. And 0.5. So half a centimeter on that one with 2 amps. 0.5 centimeters, which is equal to 5 millimeters. All right, we'll see what happens when we get down to hardly any here. All right, so here's my last one at 1.5 amps. Got it all hooked up. How far will it pull it? 3 millimeters. Right about 4 millimeters. And right about 3. So we'll put 3.3 millimeters. 3.3. Sorry, it should be 0.33 centimeters, which is equal to 3.3 millimeters. Okay, and I had a 5 or half an amp one up there, but it would not pull it at all. So I'm just going to delete that one. Okay, all right, and that's our first data table. So in our first video, as we see here, and you can see this, what we looked at is how changing the number of, or sorry, not our first video, our first experiment, changing the number of amps, right, starting at 1.5 all the way up to 6, has an impact on the distance or the magnetic field. So more electricity, more electrons flowing through the wire, and this was all done with 75 wraps of the wire, how this increases, right, as we see 1.5, 3.3 millimeters, up to 6, it gets all the way up to 18 millimeters. That's 1.8 centimeters that it pulled this from. So a steady gradual increase over time there. So now we're going to go on and we're going to see with a 6 amp plus battery, a 6 volt battery, how will changing the number of wraps. So I'm at 50 wraps, 75, 100, 113-ish, 125, and 150. How will changing the number of wraps of wire have an impact when the amount of electrons flowing through is kept constant? So the first thing I'm going to do is hook up my electromagnet. This is at 50 wraps of the wire. And we'll check the distance that it pulls this from. Whoa, 1.2. I got to reset it each time. 1.2 again. One final test. And that was about 1.3. I'm going to say 1.2. 1.22. So this is our next experiment. And this is with 50 wraps, and it pulled it 1.2 centimeters, which is equal to 12 millimeters. All right, let's test it at 75. Pause for a second to get that set up. Okay, so now we're at 75 wraps. We're still at the 6 amps. So we're changing the number of wraps. That's the variable, and we'll see how it has an impact on it. Wow, that went all the way up from 1.6. Was 1.8. 1.8 again. We'll just average that at 1.7. Say 1.75. Look at your data table. That's what we should have put. 1.75. Actually 1.78. We'll round it up. 1.78 centimeters, which is equal to 17.8 millimeters. All right, so that was our 75 wrap one. Now we're going to throw on our 100 wrap electromagnet. This might not be perfect, but what we should see is a general trend in the data. General trend. We'll talk about that a little bit later. Okay, so here we go. 1.8. About 1.5. And about 1.6. So let's round that up. We'll say about 1.65. 1.65 centimeters, which is equal to 16.5 millimeters. And this was with 100 wraps. So now we're going to go down. We're going to do 113 wraps and see what kind of an impact that has. Now, remember I said before, this is a larger gauge wire. So So this might have some impact as well. But we'll see. If we can get through this, my battery's about to die, so I want to try and get through it. So all hooked up. So, oh, battery's now hooked up on the other side. Hook it up there. Here we go. And that hit us from about 2. 2. And 2 again. Let's unplug that one. So that was 113 wraps, and that was 2 centimeters, which is equal to 20 millimeters. All right, let's go down and we'll do 125. See what kind of an impact that has. So remember I said this one is a smaller gauge wire. So I assume that's going to have an impact on this. And it will probably make it less of an impact. It probably will not be as strong. But we'll see those are wrapped pretty tight. Yeah, so as I thought with this one, just because it's a smaller gauge wire, I think I'm just going to take that one out, and we'll just leave it at the 113. We'll use that one, and we'll go back to 150 with our larger gauge wire. So one thing we also have to remember here too is our battery is dying every time we're doing this. So we're actually decreasing a little bit the battery. So we'll see what happens here with 150. Right at 2.1. About 2. Definitely losing some on the battery, I think. Turn the angle back, about 2.1. So I'm just going to put that one at about 2.1. 2.1 centimeters equals 21 millimeters. All right, and that's actually, we're going to put that one at that's the 150. 150. All right, so I will include a graph of all of this data for each of these. But in this table, what we've noticed here with 6 plus amps, right, and that's 6 plus amps, if you change the number of wraps of wire, what we noticed is the distance it pulls it from increases, which supports the claim that the magnetic field has increased due to the change of the number of wraps of wire, which you learned about that impact. Then in the previous example, we changed the number or amount of electrons flowing by changing the amps. And we saw that that also had an increase in the distance that it pulled. So we're changing the factors that affect the force of magnetic attraction in these objects. And that is the conclusion of this lab. All the other instructions are included in the materials and assignment for this week. And thank you for participating.